Hello, folks. I'm Devansh, and I'm a developer at Tech Baron, where we focus on helping organizations navigate and adopt modern AI systems responsibly and effectively. Before we dive in, I want to set the tone for today's session. You're going to hear the word transformers a lot, not as a buzzword, not as a research concept, but as a practical capability that is already reshaping how healthcare decisions are made across claims, clinical review, member interactions, and provider operations. Think of transformers as the moment of AI where it moved from simply processing data to actually understanding context, reasoning across complexity, and supporting judgment heavy workflows like the ones we manage every day. For the next 30 plus minutes, my goal is very simple to make transformers feel clear, intuitive, and actionable. So that whether you lead operations, clinical programs, product, risk, compliance, or technology, you can walk out with a confident sense of where this architecture fits in the work you do. So let's begin with the story of how this architecture emerged and why it has become the foundation of modern AI. Let's move to the agenda. Here is the path we'll follow today. First, orientation. This is where we'll ground ourselves in what changed in AI over the last few years. Not the hype, not the marketing language, but the real architectural shift that makes Transformers fundamentally different from what came before. This section sets the context so the rest of the session feels clear and intuitive. Second, foundations. Here we'll unpack the three ideas that make Transformers powerful: self attention, parallelism, and contextual reasoning. And I'll explain them in plain language using examples from claims, clinical review, member services, and fraud detection. So the concept actually stick. And third, what Transformer enable in business. This is where we bring it home. How these capabilities translate into reduced cycle time, improved accuracy, stronger compliance, and better experiences for members and providers. So by the end, you will have a practical, business ready understanding of where transformers create enterprise value and where they don't. Alright, let's move into the orientation. Let's break this down as simply and practically possible. A transformer is a model that reads everything at once. Instead of going word by word, like older models, it processes all tokens in parallel, which means it can understand a clinical note, a claim file, or a member chat as a single connected unit. That's the foundation of its power. It uses something called self attention to figure out which words, sentences, or data points influence each other. In plain language, it learns what matters and what doesn't, the same way a clinician or an analyst zeroes in one of the most relevant details. Because of this, it builds contextual understanding. It doesn't just extract text, it interprets relationships, timelines, symptoms, contradictions, and even policy relevance. That's why transformers now power some of the text models, image models, and even multi-model systems that blend clinical notes, images, structured EHR fields, and conversations. Now it's important we are equally clear about the limitations as well. These models come with high computational cost. They are powerful but not cheap to run at enterprise scale. They also inherit biases from the data they are trained on, which matters a lot in healthcare. And they need high quality, well governed data, as performance drops quickly with noise or inconsistencies. We also face challenges around interpretability. It's not always obvious how the model arrives at a decision. And security, since adversarial inputs can mislead a system if guardrails aren't strong. The message here is balanced. Transformers are extremely capable, but they require responsible design, governance, and data hygiene. And that's exactly where an organization like ours has a real advantage. Now that we know what they are, let's look at the impact they have had. When we talk about the impact of transformers, it's helpful to look at how they have already reshaped entire categories of digital work. On the left, we start with text based applications. Transformers enable natural, realistic conversation and they even answer questions in real time. They assist with information retrieval as well. Capabilities that directly translate to member services, care navigation, and provider support lines. Next is the content generation, where articles, summaries, social posts, short form copies are included. In healthcare, this shows up as a draft clinical documentation, note summarization, chart abstractions, provider messaging, and member friendly explanations. Then we move to the code generation, models that can write, debug, or translate code. For us, it accelerates internal tooling, operational automations, and data pipeline development. In image and art creation, transformers generate visuals, product mockups, and structured outputs from images. In our context, this translates to chart digitization, document interpretation, EOB processing, image QA, and other workflows involving unstructured visual content. And finally, marketing and creative work. This includes generating creative variations, personalized materials, or campaign ideas, which can support targeted member communications, health engagement journeys, and population specific outreach. The big takeaway is that transformers haven't just advanced in one field, they have transformed in many. And every one of those categories has a direct parallel inside Optum and UHG, from clinical to operational to experience driven workflows. Now that we have seen the breadth of impact, let's look at the evolution that made this possible. This slide captures the moment AI fundamentally changed, and the best way to understand transformers is to see the journey that led us here. On the left, back in the days, 1990s, we had what I call the prehistoric era. Models were simple, rule based, and brittle. They couldn't handle real world complexities. Then, in 2000, recurrent neural network arrived. They process text sequentially, one at a time. That was useful but slow and struggled with anything long or nuanced, which makes them a poor fit for clinical notes, multi page claims, or multi turn conversations. In 2010, LSTMs and GRUs improved memory but still face the same bottleneck. They could only look at a limited window of information at once. Then in 2014, Badanu attention appears. This was the first time models could highlight important words, but only locally, not globally. In 2015, we see Luange attention, also called dot product attention. This takes the idea further, but again, still layered on the top of sequential model itself. And then 2017 happens. Google publishes the transformer architecture, introducing the formula at the top of the slide where parallelism into context awareness is what makes transformers so powerful. That formula ignited modern AI. It replaced the entire sequential processing world with a model that can read everything at once, understand relationship across the entire document, and scale to the size of real healthcare complexity. This is the breakthrough that powers every major model you have heard about since, from GPT to medical summarization tools to multimodal systems that analyze text, images, and structured data together. Now that we have understood where transformers came from, let's walk into the mechanism that makes them so powerful. This slide uses a playful comic to capture a very real moment in AI history. Around 2016-2017, the AI community was struggling with a fundamental challenge: how do we improve machine understanding of language? Back then, early systems processed text sequentially, one word at a time. That created two big limitations. First, they were slow because every word depended on the word before it. And second, they were context blind, losing information as sentences got longer. RNN based models like LSTMs were the best we had, but they simply weren't capable of holding the full meaning of long clinical notes, multi page claims, or member conversations with multiple back and forths. And then the breakthrough happened. In 2017, a research team at Google proposed a radical answer. What if we use only attention? No recurrence, no sequential bottleneck, just a mechanism that looks at everything at once and figures out what matters. That idea became the transformer architecture, and it enabled true global and contextual understanding, the ability to connect early symptoms with later diagnosis, or map policy rules across an entire claim packet, or even track a member's intent across a long conversation. This is the architecture that powered the explosion of modern LLMs and multimodal AI. Everything we see today, from medical summarization to intelligent agents, is built on this core mechanism: self attention. And next, we will unpack what is this attention mechanism and what it actually does. This slide gets to the heart of how transformers actually think. Attention tells the model which word influences each other. Very similar to how you read a document. When we read, our eyes naturally gravitate towards certain words, the one that matters in that moment. We hold them in focus, while other part of the text remaining are in the fringe, and everything else fades into the background or in the margin. This image is exactly showing that: a sharp center where your attention sits, a surrounding region where you're still aware, and a blurred margin where information is present but not important right now. Transformers mimic this process. Instead of treating every word equally, the model learns to highlight the word or token that shape meaning, the symptom that matters, the timestamp that changes interpretation, the phrase that signals risk, or the policy rule that ties everything together. This is why transformers outperform older models. They don't just read, they prioritize, they contextualize, and they even assign significance based on the relationships across the entire document. Let's go deeper into self attention, the engine that's powering all of this. This slide shows a powerful idea. Transformers don't just see everything, they focus on the parts that matter, just like we do. When you read a sentence or look at a picture, your brain doesn't process every single pixel or every word equally. You zoom into the object that carries meaning. Let's just take example of these images where the frisbee, the dog, the stop sign, the girl, the people on the boat, the trees. In the images here, the highlighted regions show where the model's attention is strongest. It's automatically identifying the word or concept that defines the entire statement. This dynamic focusing, this attention weighting is exactly what enables the model to reach deep understanding rather than surface level matching. It knows which part of the sentence or an image dominate the meaning, and it prioritizes those relationships during reasoning. In healthcare, this is critical. Attention helps a model detect the symptom that changes triage priorities, the timestamp that changes medical necessity, the subtle phrase in a provider note that signals risk, or the key field in a claim that determines adjudication logics. So, the big takeaway for the slide is simple. Transformers mimic human focus but do it at machine scale, consistently, instantly, and across thousands of documents. Now that we understand how attention feels in practice, let's go a level deeper into self attention. Now we get into the engine behind everything a transformer does, self attention. Unlike older models that read text in a straight line, left to right, a transformer compares every word with every other word in the sentence, instantly and in parallel. In this simple example, the model is deciding which word matter most. When interpreting the sentence, he is watching a French show. It assigns high attention to the relationship between he and show and low attention to the small connecting words like is or are. That same mechanism lets the model understand nuance in real healthcare, which symptoms connect, which medications interact, which timestamps matter, or which phrases change the interpretation of medical necessity. Self attention enables the model to interpret timelines, casualty, severity, and intent, all of which are critical for clinical triage. Claims, interpretations, and fraud detections or even the high stake decision support are backed by such kind of mechanisms. So the takeaway for this slide is simple. Self-attention gives transformers the ability to reason about relationships, not just read text. That's the capability older models never had. Now let's see how this same idea extends into image understanding. Self-attention is just for text. That's a wrong thought, I believe. Transformers use the same idea for images as well, but they do something very clever to make it work. Instead of treating an image as one giant block of pixel, they break it into patches, small sections, and then learn the relationship between those patches. Here you can see the model discovering which patch matters the most, the ears, the eyes, or the shape of the face. Just like in text, it builds a map of relevance, but this time across visual features. This eliminates the need for handcrafted rules or templates. Traditional systems require engineers to define what a form looks like, or where the fields are located, or how a chart layout should appear. But a transformer learns those patterns directly from pixels. This capability is extremely important for healthcare and payer operations. It allows model to detect key fields in provider submitted documents, regions of interest in medical images, anomalies or inconsistencies in EOBs, critical structures in imaging QA. So the big takeaway is this, that transformers don't just process image, they interpret them. They understand relationships between regions just as they understand relationship between words. And next, we will look at why this makes so reliable in large scale operational settings. Now that you understand how transformers look at image, let's talk about why this matters for healthcare operations and clinical workflows. Vision transformers deliver something that human reviewers and even older image models struggle with: perfect consistency. They don't get tired, they don't overlook details, they don't vary from reviewer to reviewer. On the bottom of the slide, you see real chest X-ray comparisons. The middle column shows the ground truth region that should be detected. The third column, the VIT model, that pinpoints exactly the region with focused and stable attention. By contrast, older models like ResNet are much noisier. They highlight broad irrelevant areas. This is common when images are complex, noisy, or diverse, which is typical of real world clinical and operational documents. This is why transformers outperform traditional models on document image extraction, chart digitization, EOB interpretation, clinical imaging QA, and workflow automation tasks that depend on accuracy and consistency. And remember, this isn't just about medical imaging. The same reliability applies to intake forms, handwritten notes, provider submissions, and any visual data flowing through payer and provider system. So the key message here is simple. Transformers bring stability, precision, and scalability to visual workflows that have historically been high variance and high effort. Next, we will explore how transformers use this attention mechanism across entire document. Up to this point, we have talked about attention, how transformers decide what matters. Now let's talk about parallelism, which is how they operate so quickly and at scale. Unlike older models that read text one at a time, transformers read entire documents simultaneously. That means they don't build meaning piece by piece, they build meaning all at once. They analyze every sentence, every paragraph, every field, and connect relationships between all words, not just the one next to each other. This gives them the ability to understand nuance, intent, and context the same way a seasoned clinician or claims analyst does, by synthesizing the whole picture, not just the fragments of it. And when you bring this into healthcare, the impact is significant. Transformers can surface insights from long clinical notes, multi page claims, prior auth documents, appeal packets, or complex member conversation with far greater accuracy than older systems. So, the key message on the slide is simple. Parallelism is what gives transformers their speed and their depth. Let's get in the process and understand the complex healthcare text with completeness older models could never achieve. And next, we'll connect this to the business value, how parallelism becomes a real operational accelerator. This slide brings the concept of parallelism back into the business world, specifically the workflows we manage every day. Here is how older AI models worked. They operate sequentially. Task A had to complete before task B could even begin. This is the same limitation we see in manual review processes. You can't summarize a note until you finish reading it. You can't adjust a claim until you have reviewed all the fields. You can't assess fraud risk until you have checked every supporting document. Transformers break that bottleneck. They process everything in parallel. Task A and B and everything in between happens simultaneously. The model builds understanding of entire document or conversation all at once. This instantly reduces latency across key workflows: claim adjudication, clinical review, prior auth, member service interaction, and even chart abstraction or code supporting. Think about the operational impact. What used to take minutes or sometimes hours can be reduced to milliseconds, not by cutting corners, but by giving the model a view of the entire context at the same time. And when you pair this speed with deeper understanding, we discussed it earlier, you get a system that is not only faster, but more accurate and more consistent. So the big takeaway here is straightforward. Parallelism is the force multiplier. It's what allows transformers to support high volume, high variability healthcare workflows at enterprise scale grade. Now let's look at how this parallelism and attention come together inside the transformer architecture. This slide shows the classic transformer architecture, but I want to explain it in a way that maps to the workflow all of us deal with every day. Think of the encoder as the part of the system that understands. It reads the entire input, whether that's a clinical note, a claim file, or a member conversation, and it builds a complete contextual representation of what is happening. It is essentially saying, let me absorb everything, make sense of it, and form a structured understanding. Then the decoder takes over. This is the part of the system that acts. It uses the encoder understanding to generate the final output for the task, a summary, a recommendation, an extraction, a justification, or even a next best action. Together, they allow the transformers to translate meaning into action. And that's why this architecture is such a natural fit for healthcare, where every decision requires both comprehension and action. This architecture enables capabilities like summarization, distilling long clinical notes or appeal into essential elements, extraction and reasoning, pulling out diagnosis, procedures, timelines, or key facts while understanding how they relate. Insight generation, identifying risk, fraud signals, medical necessity elements, or operational patterns. So if the earlier slide were about how transformers read, this slide is about what they do with that understanding. With this foundation, we can now turn to practical question. Where does this architecture deliver the most value in healthcare workflows? When we look across the healthcare enterprise, payer and provider sides, we see a common pattern. We operate in text heavy, image heavy, and high volume environments. And this is exactly where transformers excel. Whether we talking about large language model, foundation model, or even vision transformers, they all share the same strength. They can generate, interpret, and reason over data at a scale humans simply can't match. In the middle, you see the core capability, data generation, text, images, structured field, synthetic data sets. This isn't just about creating content, it's about creating inputs that improve downstream workflows. And on the right, we see the direct impact on healthcare workflows. Synthetic data to safely train models without exposing to PHI. Drug discovery accelerated by multimodal reasoning. Medical diagnosis support through pattern detection, patient education, and personalized medicine powered by contextual explanation. Healthcare administration tasks like claim review, eligibility verification, and coding assistance. Clinical documentations includes summaries, abstractions, structured extractions, medical education and training using generative data and simulated cases. The real message here is that these technologies aren't theoretical, they are already enabling reduced manual burden, higher accuracy, fewer handoffs, and much shorter decision cycles. And across Optum and UHG, these are the exact pressure points, places where massive volume meets complex rules and where operational efficiency directly affects member and provider experience. With the right guardrails, transformers don't replace clinical or operational judgment, they amplify it. As we wrap up, I want to leave you with one clear message. Transformers aren't just a new technology, they are a new capability for healthcare. They allow us to see across documents, conversations, and images with a level of consistency and depth that simply wasn't possible before. And when applied with the right governance, privacy controls, and clinical oversight, we get the maximum output out of them. They become a real operational advantage, reducing burden, increasing accuracy, and improving both member and provider experience. As leaders across Optum and UHG, you are in a unique position. The call to action is simple: start small, start responsibly, start where volume, complexity, and manual efforts converge. That's where the ROI appears first and where these models can make work meaningfully better. Thank you for your time, your attention, and your leadership. I'm happy to take questions or go deeper on any of the topics we have covered today.